Alrighty then. Welcome. Oops, there we go. Welcome to another episode of Metallist Math. Today we're going to talk about some practice questions for the GED math test to help you get your high school diploma. So we're going to do these pretty small chunks. We're going to do like 5 at a time and let you wrap your brain around those. But I'm going to try to show you some interesting techniques as far as, even if you're not sure what to do, figuring out ways to eliminate certain answers and things like that. So let's go ahead and hop right in here. All right, so this first one's pretty self-explanatory. This is some basic algebra here. So it says 3x equals 24. So kind of think back to the old days of like flashcards. When you used to have flashcards, they might have something like this, where they would have 3 times and then blank equals 24. So this is asking you 3 times what number gives us 24. Well, at that point, you can just plug in numbers over here. So the first one is 8. So if you do 3 times 8 and, use your calculator, I'm not sure what the actual requirements are, but I think you can use the calculator on the GED. I suppose I should find that out for future reference. So we could take this guy here, the 8, plug it into here, and it turns out 3 times 8 is in fact 24. So that's our guy. Okay. The algebraic way of doing this, you've got 3 times x equals 24. Now, this is what we want to do. We want to get to the point where we've got a variable and maybe something multiplied by the variable on one side and the numbers on the other side, which it's already set up that way. So when you have it set up that you have x guys on one side, number guys on the other side, what you want to do is you want to divide by the number in front of the x. So remember, going like that is the same as dividing. A fraction is just a fancy version of a division problem. So 24 over 3 is really the same as saying 24 divided by 3. Okay, and 24 divided by 3 is 8. And again, like I said, as long as you can use a calculator in there, please use a calculator. You don't want to mess things up with just a math error because you were doing it in your head. Okay, so that one's pretty straightforward. Let's go ahead and check out another one here. All right, this says an attorney charges a fixed fee. Well, attorney A, so there's one attorney charges a fixed fee, so he charges $250 for an initial meeting and $150 per hour for all hours worked after that. This is a cheap attorney, by the way. So attorney B charges $150 for an initial meeting and $175 per hour. So it says find the charge for 26 hours of work for each attorney and which is the better deal. Okay, so here's the thing. On this one, they're not actually asking you for a total on these guys as far as an answer. They just know which one's a better deal. So let's think of it this way. So this guy here charges $100 more, right? So that's plus an extra $100. Okay. But then he charges 25 less than this guy. So basically what you're saying is for every hour you hire this other guy, even though you saved $100 to start with, he starts gaining $25 for each of the hours that he works. So the point is 25 times 4 is 100. So after only 4 hours, they're going to be the same price. And then after that, this guy's going to keep making an extra $25 over the first guy. So which one's the better deal? Definitely attorney A. Now, if you don't like that, that's fine. So what you can do then, you can say, okay, this guy charges $250 and then plus $150 an hour, and he works 26 hours. Okay, so let's see if I can break out a calculator here. And one that you can see on the screen, so we can do that. All right, give me just a second here. It's a calendar, I don't want that on a calculator. Hang on. All right, so calculator, that's more like it. All right, so see if we can bring this guy into the picture. And I'm trying to set it up here on another screen real quick. And I'll bring it in here. Here we go. So I'm going to bring this guy in. All right, so then what we've got here is we've got the $250. That was his initial fee. And then plus, we're going to multiply 150 times 26. So that's going to be 4150. Okay, so the second guy charges 150 bucks, but then 175 times the 26 hours. Okay, so we'll break out the calculator again. So for this one, we're going to do, let's clear him out. So we're going to do 175 times 26 equals 4550. So already he's more, and then on top of that, he's going to charge another 150 bucks. So this guy's 4,700. Okay. So obviously, the first guy is a much better deal. Okay. So you use your calculator, or you can just logic it out here and say, well, this guy, I'm going to gain that $100 I didn't have to pay to begin with after only 4 hours. So whatever works for you, that's the main thing. Okay. Let's go ahead and check out a few more. All right, this one says Ken found that 20 of 50 students surveyed in the lunch line liked enchiladas the best. Sounds good. So it says there are 520 students in Ken's middle school. Predict how many like enchiladas the best. Okay. So what this is saying, for every 50 students, 20 of them like the enchiladas the best. Okay. Well, we don't have 50 students. We actually have 520. Okay. So I'll show you a couple different ways to think about this one. Okay. So we want to know how many of these kids like the enchiladas the best. So basically what we're doing is we're scaling this up from 50 to 520. And we're going from 20 up to some number. Okay. So how would we figure that out? So what we need to do here, there's a couple different ways you can go about this. When you have a fraction that's equal to another fraction, that's known as a proportion. And with proportion, you can cross multiply. So we cross multiply this way, we get 50 times x. And if we cross multiply this way, that's going to be 20 times 520. So this is definitely calculator city. So let's break that out. Okay, so we clear it. And we've got, what was that again? It's 520, right? So 520 times 20. Pretty good size number, right? But then what we do then is we say, okay, so I've got 50x equals, I totally forgot it again, hang on. 10,400. Okay, so let's get him back out of here. So we got 10,400. And then remember what we do with algebra, we divide by the guy in front of the x. So we divide this 10,400 by 50. Calculator time again. So I'm going to divide him by 50. So when we do that, we get a prediction of 208. So that's that guy right there. Now, another way you could think about this is we've got 50 over 20. Okay? So if you take your calculator, because 50 over 20, since these zeros are here, you can actually divide those out. It's the same as 2/5. But even if you didn't know that part, that's okay. Because what you can do is you can take your calculator, let's clear them out again. And we say, so 20 over 50 is the same as saying 20 divided by 50. That's 0.4. So then you take that 0.4 and you multiply it by 520. Because what this is saying is if you have 20 people out of 50 people, that's 0.4, also known as 40%. So 40% of the people like the enchiladas the best. So then you take the 0.4 and you multiply him by 520, and we get the same answer. Okay, so again, I want to present some different ways to think about this, and you go with whatever works for you. Okay, let's go ahead and move on. A couple more here. So it says a full-grown horse should eat a minimum of 12 pounds of hay each day and may eat more depending on their weight. So it says how many pounds minimum should the horse eat over a year? Okay, so now they're making some assumptions here. They're assuming that we know there's 365 days in a year. They're also assuming that it's not a leap year, which would mean there's 366. So the best thing to do is probably just assume they're going to go with 365. So then this is just going to be 365 and then 12 pounds a day. So multiply by 12. So again, calculator city. So we will clear this out. We go 365 times 12 is 3480. I did that backwards, it's 4380. And there's our guy. So that wasn't too bad. But like I say, they kind of should probably say that, assume that there's 365 days in a year. So probably not the best worded question, but we got through it. All right, one more for today. So visiting Orlando, Maria needs to rent a taxi to get from a hotel to a restaurant. Taxi company charges a flat fee of $3 for using the taxi and 75 cents per mile. Again, probably a pretty cheap taxi. Okay, so it says write an equation in slope-intercept form. So slope-intercept form, when they say that, that's going to be y equals some number times x plus some other number. Okay, so what the numbers are, anytime you have a flat fee, a starting fee, something like that, that is what is known as the y-intercept or the regular number. So the regular number goes here. So $3, you could probably just write 3. Okay. The part with the x, this is when something happens, like per this, per that, per mile, perhaps. Yeah. Okay. So any number that's being changed by so much, per minute, per mile, per whatever, is going to go with the x. So then that means this guy, I'm going to cram this in here a little bit. So it's 0.75 goes into here. So 0.75x plus 3. So we check our answers out. And here's our guy. Okay. And I'm sure we'll have some other problems like this, but anytime you have a linear equation, like I said, the y-intercept, this is a starting point. A starting point, initial fee. Like, for example, when a plumber pulls in the driveway, he charges you $80 to pull in the driveway. I'm just making that up. And then so much an hour to fix your problem. So here, the cab charges you $3 just to pull up. There's your starting fee. And then for every mile you travel, so this is the part that changes. So every mile you travel, they're going to add an additional 75 cents, which again is pretty cheap, especially for Orlando. Okay, guys, well, that's our first one. Like I said, this is going to be a series. I think typically the practice tests have 25 questions. So I'm assuming that the GED has 25 questions. But let's stop there for today. I hope you enjoyed this. Hope it helped you out. Be sure to like, comment, and subscribe. And we'll see you all next time. Thanks for watching.